Hello students, welcome you all for Advanced Communication Laboratory. Today we are going to, I'm going to give some introduction about Advanced Communication Laboratory. So this lab consists of three set of experiment. One is the experiment based on microwave, and second one the experiment based on optical communication, and third one the experiment based on the communication. Okay, so first we are going to see the experiment based on the microwave. For that, you should know the basics of microwave engineering and components, that is active and passive components, and microwave test bench. Okay, so first the experiment is nothing but study experiment. Okay, we are going to study the basics of microwave setup, that is microwave test bench, active and passive components and their use in the microwave test bench. Okay, so let us look at, so this is a block diagram of microwave test bench. It consists of klystron power supply, klystron tube, isolator, variable attenuator, frequency meter, slotted line, load, and VSWR meter. Okay, so these are the basic elements of microwave test benches. Okay, and the next slide I'm going to show the, so this in terms of block diagram. Next to this here, this picture shows the same microwave setup. So this is a microwave test bench using reflex klystron as a source. Here the microwave source is a reflex klystron. Okay, so this is a klystron power supply. The main function of the klystron power supply is to energize the klystron tube. Okay, so this klystron tube will generate the microwave energy, and it will be this tube will couple the energy with the klystron mount. Okay, so this is a klystron power supply, reflex klystron power supply. Here the control panels, control knobs will be there, and for these knobs for the adjustment of power supply. Okay, and this power supply probe will be connected to the klystron mount. Okay, so this is a klystron tube with the klystron mount. So once the power we power on to the klystron power supply, the energy will flow to the power will be given to the klystron mount, and the klystron tube will generate the energy, and this tube coupled with the mount, waveguide mount, the energy will start flow through the waveguide. Okay, so this is a klystron tube. Since so this klystron tube is a hot, so that is a very heat. Okay, it's a in which the filament is there for generating the electrons, and will be very hot. So in order to cool down the this klystron tube, a cooling fan should be near to the klystron tube. So whenever we are switching on the klystron tube, before switching on the klystron tube, we need to ensure that whether the fan is on. We need to, it's a very it's very important. Okay, so once the energy is coupled with the waveguide, okay, the next element will be isolator. The main function of this isolator is to allow the power only one direction, from this side to this side, only one direction. Okay, due to any mismatch in the impedance mismatch in the or loosely coupled element, the reflection will back to the source, and it will affect the source. So this will be avoided by the isolator element. So the isolator will allow the energy flow only one direction, in the forward direction, and reverse direction it will completely absorb the power. Okay, so it's called as isolator or uniline. The next element is nothing but variable attenuator. So the main function of variable attenuator is to reduce the power flow, and here the tuner is there. So this, by using this tuning element, you can able to control the how much amount of power flowing in the waveguide mount. Okay, in the waveguide elements. Then the next element is that frequency meter. So the function of the frequency meter is to measure the how much frequency is going on the waveguide. Okay, and followed by the frequency meter. Next element is a slotted line. The main function of the slotted line is to measure to carry out the various type of measurement. For example, frequency, wavelength, okay, unknown impedance. So these are the some of the uh, measurements you can carry out by using the slotted line. It's a very important component of microwave setup. Okay, so after the slotted line, and the next element is that detector mount. So this is a crystal detector mount. Inside a crystal oscillator will be there, and this crystal will detect quartz crystal will be there. This crystal will convert the microwave energy into electrical energy, and then it will be given to the VSWR meter. And this VSWR meter will measure the how much amount of voltage is flowing in the waveguide. Okay, so this is about the basic setup of microwave test benches. So you can construct the microwave test benches using reflex Klystron tube, or else, and next one, by using the gun diode setup. Okay, so this is a microwave test bench, the same setup. The only is here the source of oscillation is different. So previously the source of oscillation is here by using a reflex Klystron tube, but here is in terms of gun diode. This is a solid state device, whereas previous one is a vacuum tube. Okay, so reflex Klystron is a vacuum tube, and this is a solid state device, gun diode. So for that you will be using the gun power supply and gun diode, and the remaining one more element is there, pin modulator. Okay, for the modulation of waveforms. Okay, whereas other element you see that everything will be same as that of the previous one. Okay, next we look at that. This year again microwave test bench using gun diode or as a source. Okay, so this is a gun power supply, and these are the control knobs. Front panel having the control knobs about the for the gun power supply, and this is a gun diode. Okay, and this is a waveguide mount, and this one is a tuner for adjusting the amount of power, that is amount of energy is flowing in that. And next one is this isolator. Here you can see the arrow mark to indicate the power direction, power flow direction, only one direction. Back wave propagation will be observed, and this is a pin modulator. Okay, to modulate the waveforms. Okay, and next one is a variable attenuator. It will reduce the power. Okay, then this one is a frequency meter to measure the frequency, and slotted line. Okay, to measure the unknown impedance, VSWR, wavelength, etc. And next one is a detector mount. It will convert the energy, that is the microwave energy, into electrical energy, and then by using the VSWR meter you can be able to carry out the measurements, various type of measurements. Okay, so in this place, either you can connect the VSWR meter, or you can also connect the CRO for carry out the measurement. If you connect that instead of this VSW meter, if you are connecting the CRO, then you can able to view the square, that is a square wave in the uh, CRO. Okay, and next one, these are the active components. So this is a reflex Klystron tube with waveguide mount. Okay, and this is a waveguide reflex Klystron tube, and this is a waveguide mount. Okay, so the energy, microwave energy, will be coupled, induced or coupled with this waveguide mount. And here you see that the reflector will be there. So the energy will be in the forward direction, not in the reverse direction. And the amount of reflection can be controlled by this tuner. And likewise, this one is a gun diode mount. Here this backside is a gun diode with the heat sink, and this is a waveguide mount. And here also the power reflection will be controlled by using this tuner. Okay, only the power will flow only in the forward direction, not in the reverse direction. And these two are normally will be using the microwave sources in the lab classes, because these are the low power sources. So normally approximately the power source of 1 watt, nearly approximately 1 watt of power, microwave power, will be generated by using gun diode and reflex Klystron oscillator. Okay, and these are the various passive components of the tube. Whereas the passive components, you know that it will not generate the energy, it will modify the energy. Okay, this isolator will allow the power only one direction, and this is a magic the combination of E plane T and H plane T. Okay, and this is a E plane T, and this one is a H plane T, and this is a circulator, and this is a frequency meter. Okay, and then this is a variable attenuator. Already you know that this is a L bend, and this is a matched termination to match the waveguide termination. Okay, that is n terminal equipment, and this is a slotted line. Okay, and this is a rat race or hybrid ring. So these are the various microwave passive components. Thank you all.